this is when I feel like we start getting into some new type of functions. Start talking about quadratic functions and their properties. Now, we already talked about quadratic equations, if you recall. The quadratic equation was 0 is equal to ax squared plus bx plus c. A quadratic function is going to follow that same format. It's just instead of 0, we're going to have f of x. So a quadratic function is a function of the form f of x is equal to ax squared plus bx plus c. A, b, and c are any real numbers. So they can be pi, they can be 3, they can be 1/2, whatever. The only thing that's necessary is that a is not 0, because if a was 0, it would just be a linear function. You wouldn't have that square term. The square term is what makes it a quadratic, and having that square term as your highest degree on the variable is really what makes it quadratic too. Because if you increase the degree again, it'd be like a cubic, right? Now, one of the things here is that the domain of the quadratic function is a set of all real numbers. Think about what we talked about with domain. There's no x in the denominator. There's no x under an even root, so x can be whatever it wants. Negative infinity to positive infinity. Oops, sorry, didn't mean to scroll there. So the domain of a quadratic can be negative infinity to positive infinity, unless someone changes it manually. I mean, it can't be done, but most of them will be this. And what I mean by that is they give you the function, they state the domain is something different. Which is something we may see in 6. And you're probably familiar with what a quadratic function's graph looks like. Everybody knows what it's called? Parabola, yeah. And so you got two types of parabolas. You have a parabola that's shaped like this, and one that's shaped like that. And so, sorry, my nose. There's two ways that this can be done. They can either open up, which is like it's going to collect water, or it opens down, which is like you're pouring the water out. Now, the way to determine if it opens up or down is pretty simple. If you get it into that form, ax squared plus bx plus c, if a is positive, it's going to open up. If a is negative, it's going to open down. The reason behind that, if you go into calculus, may dawn on you. But for right now, just remember it. If a is positive, it opens up. If a is negative, it opens down. The line that bisects the parabola or splits it in half is called the axis of symmetry. It's an axis, and the graph is symmetric with respect to it. That's why we call it the axis of symmetry. And that axis of symmetry passes through a point. And that point is what we call the vertex. And so notice when it opens up, the vertex is what? It's your lowest point, right? It's a minimum. It'll be the absolute minimum. When it opens down, the vertex is on the apex, so that like hill. And so that's going to be an absolute maximum. So your vertex is your highest point here, your vertex is your lowest point here. Any questions on that? All right. So how do we find the vertex and the axis of symmetry of a quadratic function? So people always seem to struggle with this, but I don't know. I don't. Well, but all you need to do is plug it into a formula to get the value. Now the vertex. Oops, I'll be writing. We usually say it's a point HK. H comma K, both lowercase. That's usually how we represent the vertex. You know, we do X comma Y. Well, the point here we say is H comma K. And the point here as well will be H comma K. To find H, you're going to do negative B over 2A. That's going to give you the X value of the vertex. You may realize something very similar to the quadratic formula. It's just missing the plus or minus square root of b squared minus 4ac. So it's just that first part, and that's actually a really good way of thinking about that, but I think it's a little too advanced for this class. I tried to teach it one time. I think I confused it, but it's interesting if you ever want to look at it. Just let me know. Do it outside of class. But that is basically how some of that is related. And so that's what makes it easy to remember in my mind. H is going to be negative b over 2a. Plugging those values into that formula. Boom. Any questions on that? Now, what I don't like is how the book writes this. If you want to find the k value, it's the y value that goes along with h. So all you need to do is do f with h. You find h, plug it into your function, you get the y value, that's k. Boom. It's done. All right. And to find the axis of symmetry, all right. To find the axis of symmetry, it's a vertical line, right? And so to write a vertical line, we usually write it as x is equal to something. X is equal to a, I think is how I've been writing it. Oh, that's a bad choice, but x is equal to some value, right? And since the x value of a vertex is h, the axis of symmetry is always going to be x is equal to h. Don't forget that x is equal to. In the homework, it may write it for you and just ask for the value to be plugged in there, but it's always been a problem on paper test. You forget to write the x is equal to. It's an equation of a line. We want x is equal to h. Any questions on that? So remember, if it opens up, the vertex is going to be the absolute minimum. That's going to be h comma k. If it opens down, the vertex is going to be your maximum. That's going to be h comma k. So let's talk about what's the range going to be. So we're going to look at both of these graphs because it's different for both of these. We talked about domain already, negative 30 to positive 30, but the range can happen in two different ways. If we look at that first one, the one that opens up, what do you think the range is going to be there? Anybody know?
The lowest point.
Okay.
The lowest point is.
And what's that lowest point? It's h comma k, right? And so the y value there is what? K. And so the range is going to be from k to infinity. And we're going to include the k because it's the actual value on the point. Any questions on that? What do you think the range is going to be for the other one when it opens down? I mean, negative infinity k. Once again, we include the k with a bracket. And that's it. So luckily, linear functions, quadratic functions, those are pretty easy to get the range of. We'll talk about some functions that are more difficult later on. But yeah, that's basically everything about finding most of the properties, and there's some stuff we still got to cover, but that's the main things about finding the properties of a quadratic function. So I think next we have an example. Yeah. So we want to locate the vertex without graph. And we can talk about some other stuff too as well. So the first thing I do when I get a quadratic function and I need to determine some stuff about it, I want to decide, does it open up or down? It's the easiest thing to do, and it gives me a lot of information just from it. So if we look at this one, negative 3x squared plus 6x plus 1, does that open up or down?
Down.
Now, how do we know?
A is negative.
A is negative 3, which is less than 0, so that means it's going to open down. So we know our graph is going to be shaped like that. It could be wide, it could be skinny, it could be located wherever, but we know it is shaped like that. And now we know that our range is going to go from what? Negative infinity to k, because it goes all the way down to negative infinity. That's some good stuff too. The next, what do we want to try to do? Let's find h and k. Let's find the vertex. So to find h, remember it's negative b over 2a. The easy part of a quadratic. And so for us here, that's going to be negative 6 over 2. Oh, I say 2, I wrote 3. 2 times negative 3. There we go. Oh, hey, that's not bad. And so this is going to be negative 6 over negative 6, which is 1. So we know our h value. Know our vertex is 1 comma something. We want to find that something. We're going to figure out what. Oh, let's write it this way. We're going to say k is equal to f of 1, which is going to be negative 3 times 1 squared plus 6 times 1 plus 1, which will be negative 3 plus 6 plus 1 is 4. So my vertex is 1 comma 4. Any questions on that? So you find h with negative b over 2a, whatever that value is, plug it into the function, get your y value that goes along with it. That is the k. All right. So once we got that, I didn't give myself much room here. If I want to know the axis of symmetry, what is it going to be? X is equal to whatever h is, in this case is 1. Yep, good. Any questions on that? And for fun, what is the domain of that function? Yep, it's all real numbers, negative infinity to positive infinity. And the hard one, what is the range? negative infinity, starts all the way at the bottom, goes up all the way to the vertex, which is 4, and we include the 4. Any questions on that? All right. All right, finding intercepts is the same exact thing we normally do. You plug in a 0 for y. If you're trying to find the x-intercepts, you plug in a 0 for x. You're trying to find the y-intercepts. What's neat is if you look at a function that we just worked with, or wherever it is, if you plug in a 0 for all these x's here and here, what do you end up with? Just a 1, right? So the y-intercept is just c. Whatever c is, give you the y-intercept. Which is nice. The x-intercept is a little bit tougher because if you set that up, it becomes a quadratic equation. So if, like we looked at the last one we just did. Now, you could factor this if possible to try to solve it. You could use a quadratic formula to solve it. Whatever you want. There are some things that we can use to help. The discriminant, like we use for the quadratic formulas. Yeah, that's what I said. Quadratic formulas. That still applies. So if the discriminant is greater than 0, it has two x-intercepts. If the discriminant is equal to 0, we only have one x-intercept, and it's at the vertex, which is interesting. And if you have b squared minus 4ac is less than 0, that means you have no x-intercept. Another way you can tell is we can find the vertex, right? If the vertex is below the x-axis and it opens up, hey, we're probably going to have two intercepts, right? If the vertex is on the x-axis, we're going to have one intercept. That's why this, oh, they didn't write it out that way. But yeah, that's basically what happens. If the vertex is above and it opens up, then it's never going to get down here to the x-intercept, x-axis, so it'll never cross it. Same thing applies if the vertex is below it, the x-axis, and opens down, it's never going to cross it there as well. So you can use the information you learned so far to determine how many you should have and then go and find them. Or you can use the discriminant or all the tools at your disposal that you've learned so far this semester. They all apply everything we've done with quadratic equations so far. Any questions on that? No? All right. Example. Looks that way. Okay, so we did, this is the same one? Yeah. Yeah, we'll do examples of the intercepts here. All right, so we got the same function, and we determined earlier that the vertex was what? 1, 4. And we know that it opens down. And we know the range is negative infinity to 4. And we know the domain is positive infinity. I mean, negative infinity to positive infinity. So I don't think we need to talk about that again. Oh, I thought it would go away if I did that. But it didn't. Well, I guess we'll write it. Now, if we want to graph this, we can graph a point and we know the shape, but it doesn't give us enough information, right? If I go and I plot 1, 4, and be here, I mean, my graph could look like this, my graph could look like this, my graph could look like this. I don't really know. So if you remember, way back, I don't remember what it was, like 3.2 or something like that, we talked about it. But to graph a function or graph an equation, the highest degree on the variable +1 is at least as many points as you need. So the highest degree here is 2, so we need at least 3 points to graph this thing. We only have 1 point. And so let's try to find some other points. Let's do some intercepts. Intercepts are probably the easiest way to do it. So let's do the y-intercept first. I like doing y-intercept for functions because they are easiest. So we have f of x is equal to negative 3x squared plus 6x plus 1. To find the y-intercept, what are we going to do? Anybody know? We'll put a 0 for x. So we'll have negative 3 times 0 squared. Was it plus? Yeah. Plus 6 times 0 plus 1. And you end up getting 1. So that means that my y-intercept is 0, 1. Any questions on that? Y-intercept is the easier of the two. All right, let's talk about x-intercept. Let's come over here. So first off, do we know if we have x-intercepts? What do y'all think? How do you know that? You're right.
Well, we have to do the g squared.
We could do that. The other thing that we know is that we have the vertex here, and it opens what? It opens down. So it's going to cross twice, I would imagine. If we want to do the discriminant to check, we can. It's what? B squared minus 4a is c. So that's going to be 6 squared minus 4 times negative 3 times positive 1. It'd be 36 plus 12, which is 48. Is that right? Yeah. Okay. Any questions with that? So we got a positive discriminant. We know we got 2. You can also use the graph information. You get the vertex up here, opens down, it crosses the x-axis twice. Now we can try to factor this thing. If we do AC, that's going to be negative 3, and B is 6. I can't think of anything that multiplies to be negative 3 and adds to be 6, which is why I was looking at that 48 kind of weird, because I knew that was going to happen. So we can't factor this. So we're going to have to use a quadratic formula. So we'll have x is equal to negative 6 plus or minus the square root of 48 over 2a, which is 2 times negative 3. And so what is that going to be? Well, 48, 4 times 12, 8 times 6, yeah. So let's break it up. Well, negative 6 plus or minus. How could we break that up? 16 times what is 48? Something, huh? 3? Yep. I don't think I have enough room to write it. So let me move the graph down some. Do it here. So we have negative 6 plus or minus the square root of 16 times 3 over -6, which would be -6 plus or minus 4 times the square root of 3 over -6. And then the last thing I can do is I can reduce that a little bit. Each thing can reduce by 2. So it looks like -3 plus or minus 2 square root of 3 over -3. You can also cancel out the negatives and make this 3 plus or minus 2 square root of 3. Because if you switch the sign on everything, switch the sign on that, switch the sign on that, and switch to plus or minus, it's still plus or minus. So that's technically right. So it's not the best one, but we can figure out about where it is. So let's see what that is about. Don't need to group that numerator when you do it though. I was about to not. What did I do? Oh, I did the arrow. 3 plus 2 root 3 divided by 3. And so you get 2.15. And negative 0.15. So we don't have the best answers to get there, but it can at least tell us about how the graph's gonna look. So we know we still have that 0.1, 4, a vertex. We know it opens down, and we know we have an intercept at 0.15, which that is about what, a fraction. And when we do a fraction. So yeah, 1 here, less than a half. It'll probably be close to here. And then you have 2.15, which would be 1, 2, a little bit past 2 there. And so this is basically what your graph will be. And it would keep going. Any questions on that? Usually you'll have better intercepts to work with. I thought this one would, until we saw the 48. I was like, uh-oh, can't take the square root of 48. Any questions on that? Oh. Let's see what we got next. All right, got 2 for y'all to try. Will these work out better? Let's see. We'll do another one. Okay, I'll let y'all try these, and then we're gonna go over it afterwards. So you're trying to find the axis of symmetry, the vertex, which you probably want to swap those. You probably want to find the vertex first, and then the axis of symmetry, and then we're gonna find the intercepts, and we'll graph them after that. So I'm just searching to see if I got a graph drawn for them. I do not, so we'll graph them by hand. So say f of x is equal to x squared minus 6x plus 9. So the first thing we'll do, let's find the vertex. Find the vertex. Remember, you want to find hk. H is going to equal negative b over 2a, which in this case is going to be a negative 6, 2 times 1. So notice that there's no coefficient on the square, that's just 1. If there's a negative on either of them, the negative goes along with it. I think we did that earlier. So we'll have positive 6 over 2, which is going to be 3. So we know that a vertex, the h value is 3. To find the k, we need to plug in that h into our function. It's going to be f of 3, which is going to be 3 squared. That's 6 times 3 plus 9, which would be 9 minus 18 plus 9, which, interestingly enough, is 0. So our vertex is 3, 0. What's our axis of symmetry going to be? Anybody know? 3, which is, remember, right, x is equal to 3. Yep. Don't forget the x is equal, right? They may have it for you in the homework. I always forget. I looked at it this morning. I still don't remember. But if they don't put it for you, make sure you write it as an equation. I'm sure my math lab will let you know. And define the intercepts. All right, so we're gonna do two intercepts, right? We're gonna talk about the y-intercept. That's the easy one. That's where we set x equal to 0. So we're gonna have 0 squared is equal to -6 times 0 plus 9, and that's gonna equal 9. So we know the y-intercept is 0, 9. The x-intercept, we're gonna make y equal to 0, right? So we're gonna set our function equal to 0. So we're gonna have x squared minus 6x plus 9 is equal to 0. The first thing you want to try to do is see if you can factor it. Now there's some other stuff, we'll talk about it later, that you can look at again. But let's try to factor this. Does it factor? AC is what? 9. B is -6. So it looks like we could do a -3 and a -3. So this is going to factor to be x minus 3 times x minus 3. And that's going to give us a solution of x is equal to 3. So we only have one x-intercept here. And that x-intercept is going to be 3, 0. Hey, that's our vertex, right? If the y value on your vertex is 0, then that's going to be your x-intercept as well. So we got our intercepts, we got our vertex, we got our axis of symmetry. They want us to graph it. Now, we only got 2 points, but we know that it's symmetric. 3. Around this. Oops. Or I'm in the wrong order. And we got what? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's up here. That's going to be a y-intercept. And so if this side is shaped like that, this side should also be shaped the same. I didn't put much curve on the first one. You'll have a tool at least to do it. You can use the symmetry as well to help you graph it if need. Any questions on that one? All right, see if we can knock out the second one. Let me just grab it. Bring up a new page. There we go. I don't know what this is about. We got 2x squared plus x plus 1. First thing we're going to do, find me the vertex. So h is going to equal -b over 2a. Should be -1 over 2 times 2. Oof, which is going to be -1/4. That's just fun to work with. To find the k, same thing. We're going to plug in the -1/4. K is going to equal f of -1/4. Isn't the prettiest thing to work with, but we can do it. And so this is going to be what? 2 times 1 over 16 minus 1/4 plus 1. And 2 times 1 over 16, we can make that 1 over 8. And this will be minus 2 over 8. And then let's do plus 8 over 8. That way everything is in the same denominator. And we'll have what? 7 over 8? Because 1 minus 2 is -1, plus the 8 is 7. So my k value is 7/8. If you get a fraction, it's fine, don't freak out. Just work it out. It's not gonna help us with graphing it much unless they break up the graph. To do our y-intercept, oh, sorry, axis of symmetry first. Axis of symmetry, I'm just gonna shorthand it. That's gonna be x is equal to negative 1/4. Just whatever your h value is. Intercepts. Let's talk about y-intercept first. Y-intercept's easy to grab. You just go grab the c value. Hey, that's 0, 1. And then our x-intercept, that's going to be the tougher one. It's going to be 0 is equal to 2x squared plus x minus 1. Was it minus 1 or plus 1? Plus 1. So we can use some information. Notice our vertex has a positive y value, right? That means it's above the x-axis. Which way does this open? Up. So we probably shouldn't have one. Now we can test it here. Let's do our discriminant. Let's do the b squared minus 4ac to c. So that's going to be what? 1 squared minus 4 times 2 times 1. It would be 1 minus 8, which is negative 7. So yeah, so there's none. We have no x-intercept.